Alright, welcome back. Here we are going to talk about evaluating definite integrals. So we are done with indefinite integrals. We are solving some of the questions with the method of what? Substitution. So here we are going to also evaluate definite integral with the method of what? Substitution. You see that with the indefinite, that is when our answer will be resolving in what? A general solution. A general solution is when you will be having C in your what? Your answer. And the C represents family of what? Constants. It makes you aware of such. That represents family of constants. Thank you. Now, let's assume the case where we have integral of a function f of s. In fact, all that we did in integration by substitution under the indefinite integral is the same thing that we are going to do here. So I may be giving you a lot of questions for you to go and try. I'm just going to introduce you the idea of the definite integral. You have this P. The A stands for lower limits, and the B stands for upper limits. Upper limits. Now, if you want to integrate this, the integral of this is going to be equal to, you see that when you integrate this, you are going to get first of all, you integrate the function, alright, and that is going to give you capital what? F. So you are going to get a function in terms of what? S, and that is the capital F. Then this A will come to this side and the B will be here, alright. So the integration is going to be capital F minus capital F of A. So that is the upper boundary minus the what? The lower boundary. So you do the substitution of, now you know all this already. You know how to integrate to get this. Just the substitution that is left. So we are going to see how we are going to do that. And here, since we are dealing with definite integrals, we don't add plus C after integration. I beg you. We don't add. No adding of plus C. No adding of plus C was here. So it's going to result in a particular solution. Alright, so let's try our first example here. Ooh. So let's have integral of, let me come with a simple question. Let's say integral of s 2s equal 3 plus s, and here is 0, 1 ds. Now this is definite integral because we have the lower limit and the what? The upper limit. So this we have here representing the what? The capital, the small what? F of s. So what we need to do is that, now here we have two methods. I will show you the two methods. But for now, here what we have to do is that we have to integrate. We have to integrate to get what? The capital what? F of s. So to integrate this, then when you integrate this, you get 2 s to the power 4 over 4 plus s squared over 2. Don't forget, right after the integration, I beg you, don't repeat the integral sign again. Then you bring your 0, 1, that's the lower bound and the upper, or the lower limit and the upper limit. So now, capital F of S is equal to S to the power 4 over 2 plus S squared over 2, which is S to the power 4 plus S squared, all these over 2. So this represents capital F of what? S. Follow. So if this represents the capital F of S, then we know that the integration is going to be equal to capital F of B minus capital F of what? A. So what is capital F of B? We know that B is going to be equal to what? 1. So what this means is that in the capital F of S, where you see S, put 1 there, 1. So when you do that, you are going to get 1 raised to the power 4 plus 1 squared over 2. So here you get 1. You get 1 there. Then you go to capital F of what? A is equal to 0. So here we get 0 raised to the power 4 plus 0 raised to the power 2. All this over 2. And here we get 0. Beautiful. So the final result is going to be capital. We know this to be what? 1. And we know that to be what? 0. So the answer is what? The answer is 1. Anytime we have a definite integral, we are going to get our results to be a value. That is why we evaluate to get a value. So there is no need for you to go and add plus C here. Because if you add plus C here and you add plus C here, after integrating this, you add plus C. After integrating this, you add plus C. When it gets to where we are subtracting, it will cancel out. So no need for you to bring it again. Alright? So let's move on to our second question. I hope it's clear. The first thing to do is to integrate the function. And it depends. The function, it can be that with the function you need to apply any of the method that we have done already. That is what substitution what method. Alright. So having this, you know that with this, you can expand and simplify alright, but let me bring to the power 4 here. That means that we have to use U substitution, alright? So U is equal to what? S squared plus 3 du ds is equal to what? 2s. So ds is going to be equal to du over 2s. And when we do the substitution, 1, 2. Alright, so here is s, here is u raised to the power 4. ds is du over 2s. We have done all this already. So the constant left here is 1 over 2. 1, 2, then we get u to the power 4 du. So let's take the integration. So 1 over 2. Now, watch. So here, we block this half. This we get u to the power 5 over 5. Or you can see that. Alright. Then we bring our what? Lower bound, which is 1, and our upper bound, which is what? 2. But u is equal to s squared plus 3. I will tell you something, okay? To have s squared plus 3 or 5, all these over 5. All these over 5. Then you bring 1, 2 to this side. Okay. Now, with here, you know that here we are going to get 1 over 10 s squared plus 3 1, 2. So our capital F of S is going to be, I hope you're following. Our capital F of S is just going to be, I have left something, and that is to the power 5. So our capital F of S is going to be, you can include it or don't. S squared, but know that let's multiply inside. It's going to our capital F of S. So we know that the integral is equal to f b, and the b is 2 minus capital A, which is what? 1. So capital FB is equal to 2 is, put 2 here, what will you get? 2 squared plus 3, all this over 5, all this over 10. And what are you going to get? And A is equal to 1. You get 1 squared plus 3, 10 for 5. So we get 2 squared plus 3 to the power 5 over 10. And we get huge value. Wow. 1680.7. Then I'll replace that by 1. Oh, 1680.7. And this is going to give us 102.4. Therefore, the integral is going to be 16,807 minus 102.4. So we get this minus 102.4, and that's going to be 1578.3. So that's going to be our final answer for that. Please, I would like to tell you something here. You see, with this, you know this already. Now, when you get to this side, you take the integral of this, bring this one here, then you bring the, we don't add plus c, you bring the lower bound and the upper bound. Now, we say that but u is equal to what? S squared plus what? 3. Now, why is it that when we get to this side, we don't do the substitution of 2 into the u, but we rather replace the result by a function in terms of x before we do the substitution? Listen, normally most of you, your mistakes or your challenge here is that when you get to this side, then you start putting the u to be equal to 2 and 1. That is wrong. The idea of definite integral is that this that we have A, B. The upper and the lower bound that we have, by default, the upper bound and the lower bound is S value, is your S values. So that upper bound and the lower bound, I'm saying that they are what? S values. So you cannot replace it by Y, you cannot replace it by U, you cannot replace it by anything, but rather replacing it by what? X. If you want to replace it by U, you have to do something, and that is what we call change of limits. And we'll do that in this video. But for now, make sure that when you get to this side, you bring back the function in X before you do the what? The substitution. Because the whole of this becomes your capital what? F of X. So the way it becomes so simple for you, then you do your substitution and you go the way. I hope it's clear. Thank you. Okay. So let's look at integral of 0 pi over 4 sec power 4x tan s ds. Choose u to be equal to sec s. So looking at this example solution, we can set our u. It's given to us, so du ds will be equal to differentiate sec s. What will you get? Sec tan s tan s. Alright, so now ds is going to be equal to du over sec s tan s. So by substitution, 0 pi over 4. By substitution, we know that u is what? The sec is what? So u is equal for tan x. Alright, and the ds here is du over sec s tan s. So this will cancel this. Alright. And when that cancels that, we haven't taken in the integration. So repeat it. So we are going to get u or 4 on top here over sec s. But don't forget that we are saying that u is equal to what? Sec s. So we can replace this sec by u times what? Du. So we get 0 pi on 4 u to the power 3 du. So the integration is going to be, because now we can take the integration u to the power 4 over 4. Don't add plus, then you bring 0 pi on 4. Alright. But here, as I said, the upper bound and the lower bound by default, the moment you see that one there, it represents s what? Values. So the integral is equal to upper bound and lower bound. But replace that. So sec u is sec to the power 4. Sorry. Oh, okay, yeah, that's it. So sec to the power 4 over 4. Alright. 0 pi of 4. So we get this to be sec pi of 4 over 4 minus sec. Or you can replace it by capital F base and do it that way. You can also do it straight away like this, can go your way. Here will be 0 over 4. And see what you are going to get for that. So you take your calculator. Sec. You know that sec is the same as what? 1 over cos. So you know how you can punch that. So you can bring all the 1 over 4 out. Alright. So this is the same as 1 over cos or 4 pi on 4 minus 1 over cos 0 to the power 4, and that is that. So you know that cos 0 is 1, so this place is just 1. And cos pi over 4 is also, make sure you are in gradient mode. That is square root of 2 over 2. So get 1 over square root of 2 over 2. So when you take the reciprocal of this, you get 2 over square root of 2. So when you subtract, then you multiply. So finally, you are going to get 1 over 4 multiplied by 2 over square root of 2 minus 1. And that is going to be 0.1036 in 4 decimal places. There is one thing to take note here is that area cannot give you a negative result. You can never, no integration is area. And since area can be negative, in the same way, evaluating integration can never give you what? Evaluating definite integrals can never give you a negative result. If you get a negative result, know that something is wrong somewhere, so that you come back and check again. Alright, so I may be giving you the rest of the question for you to go and try. Okay, because there are a lot of it that we have done here, and by now we should be able to do the rest. Let's see. Alright, so let me talk about change. Let me talk about the change of limits. The change of limits. The change of limits. And now I'm going to show you by one example. Then I leave the rest of the question for you to go and try. Change of limits. Let's say that after integration and getting it in terms of u, you don't want to quote or you don't want to substitute back the value of what? The u, which is in terms of s. But you want to maintain the u. You have to do change of what? Limits. And that is what we are going to look at it right now. So, for instance, let's see that we have integral of s squared 2s to the power 3 plus 4 ds raising to the power 5. So here your u is what? Or let me make it this way. Let me change the question and make it this way. S over 2 2s cubed plus 4 to the power 5 ds. Okay. So here, hope you can see something that here we can set u to be equal to 2s cubed plus 4. So du will be equal to 6s squared ds. Therefore, ds is equal to du over 6s squared. Then, by substitution here, s squared over u raised to the power 5, and ds is du over 6s squared. This will take away this. You get integral of 1 over u raised to the power 5, and the constant is 1 over 6. So du. Hope you can see that. Alright. So here you do your integration. Sorry, 1, 1. Okay. So you do your integration 1 over 6. Then here, let's first change this. U raised to the power negative 5 du. So 1 over 6 integral of, let's take the integration. So here, when you add 1, you get negative 4 over negative 4. No plus c, no plus c. Negative 1 u. This is where you have to take your time. Now, here we don't want to do the substitution. We don't want to bring back the value of u. So you should have been doing something here. Right after here. Right after here. Before you go and do the substitution. Here you do the change of limits. Okay, so we said u is equal to 2s to the power 3 plus 4. So if s is equal to negative 1, then u will be what? Okay, so we can see that when you do the substitution, negative 1 to the power 3 plus 4, you are going to get 2. So that is u1, because you are going to get u1 and u2. Okay, and if s is equal to, because the our value of s, if s is 1, then u will be equal to, that is u2. Do substitution to here. You get, so no more negative 1, but rather 1. And we are going to get 6. 6 for that. So here will be 6. So please, I forgot to bring back this before this. So right after taking this, you know this already. I have taught you all this already. Change the limits. So when you come to this side, you won't repeat negative 1 and 1 again, but rather bring, instead of negative 1, we had u to be what? 2. And instead of 1, we had u to be what? 6. This is what we call change of what? Limit. Change of what? Limit. You see that I'm changing it. So here will be 2, 6. So now you can see clearly here that here, if you bring back the u to be in terms of s, so that the capital F be in terms of s, and at the same time putting that s to be equal to 6 and 2 doesn't make sense, because you know that you have changed limits. So we have two methods. If you don't want to change the limits, resolve it in what we have already done. If you want to change the limits, then when you get to this side, simple. 1 over 6, 1 over 6, then you start doing the substitution. So negative, let the negative come here. So wherever you see, you put 6, because you're going to integral of f of 6 minus f of what? 2. Is that also upper bound minus what? The lower bound. So 6 raised to 1 negative 4 over 4. Even the 4 you can use to multiply this, but don't worry. That is not a concept. I've taught you this already. So 2 negative 4 over 4. That is all. That is all. And point on calculator to see what you get. Please, I beg you, I keep repeating this. We have two methods. This is change of limits. If you like it that way, no problem. But you can even see that the change of limit that is happening here is the same thing that you have done here. Sorry, by doing the substitution of the u here is the same thing that we have done, because if you bring the u here, the value you will get is 6. If you bring this u here, in the next one by substituting 2, the value you get, the value you get is going to be 2. So any of the method that you go about it is still the same thing. So let's see our final results. So we get negative 1 over 6 . So choose only one method, please. Choose only one method and be working with it. Don't choose 2 methods. But it's good to know both methods so that when it gets to your turn and you are teaching like me study here, then you will be applying that idea to also teach someone to understand it. Because it may get to your turn. Alright, hope you can see that. So when you do that, that's going to be your area. That's going to be the final answer. And also, I would like you to try on the rest of these questions. And in case of any problem, you can email to me at jampofrederick88@gmail.com. Or you have it's +233, okay, for those of you outside my country. So 05578595997. Okay, alright, so that is that. You can send to me on WhatsApp, and in case you want to also support our efforts, you can also do so. Thank you all and blessing unto them. I forgot to add this question. Jale, let me add it. So add this one to it. Integral of 5. Integral of 0,1 4 minus 2 square root of 1 minus s squared ds. Okay, so add this one to it, okay? I love you, and I want you to keep on solving more complex and difficult questions, and that makes you what? A mathematician. And as someone said, mathematicians, and mathematicians like to solve challenging questions. Alright.